Hello everyone, and welcome to Algebra 2 Lesson 7.3, Logarithmic Functions. In this video, we're going to talk about what a logarithm is. We're going to talk about how to translate between exponential and logarithmic functions, some properties of logarithms, and how to graph them. So first, let's take a look at what a logarithm is. So a logarithm is the exponent to which a specified base is raised to obtain a given value. So essentially it's asking what power of this base will give this number. For example, log base 4 of 16 is saying 4 to what power is 16? And we all know that 4 to the second power is 16. So the answer over here would be 2. So this answer in this blank is the exponent. This little number, the subscript, which is below the line, mind you, is the base. So it's saying 4 to this power over here equals this number here, which is normal script. The 4 is subscript, so make sure it goes below the line when you're writing this. Now, we can change between exponential equations and logarithmic equations in the following way. If I'm given an exponential equation, the b number is the base. It goes down here below the log. Then the a number comes next, the number that it was equal to. And then the exponent comes last. So the way I remember it is the first number is always first, then you skip to the last number, then you go back to the exponent. So it makes this little circle pattern. Now, if you want to change a logarithmic to an exponential, we do the same circle pattern. It's the base to the exponent equals the number that was here. So again, it's the first number, the last number, then the middle number. So let's do some practice where we have to change between the types of equations. Example 1 says to write each exponential equation in logarithmic form. So for this first one, we would say log base 2, and this would be subscript, of 64 equals 6. So notice this first number, last number, exponent. And it would look like this. Log base 2 of 64 equals 2. So why don't you pause the video, try the next 4 questions, and then I'll show you the answers. Okay, so for letter B, we have log base 4 of 4 equals 1. And any time you see that base equaling this number right here, this bigger number, you know the answer is going to be 1. Because it's 4 to what power is 4? It's always going to be 1. Here we have 5 to the 0 power equals 1. So this would be log base 5 of 1 equals 0. And it would be written like that. Log base 5 of 1 equals 0. In the next one, it would be log base 5 of 0.04 equals negative 2, like this. And finally, it would be log base 3 of 81 equals x, and it would look like this. Okay, so those are all of my answers. Let's try going in the other direction now. This time I'm going to give you a logarithm, and we have to find the exponential equation. The directions say to write each logarithmic equation in exponential form. So to do this, remember, it's the base, then the last number, then this. So it's 10 to the second power equals 100. We would write that like this. 10 squared equals 100. For the next one, it would be 7 to the second power equals 49. And it would look like this. So why don't you go ahead and pause the video and try and answer the next 3 questions, and then hit play to check your answers. Okay, for part C, you would have 8 to the negative 1 equals 0.125. Part D would be 5 to the first equals 5. And part E would be 12 to the 0 equals 1. like that. So those are all of our answers. Oops. And they would be written like this. Now you can always check these answers because notice 7 squared is 49. 8 to the negative 1, that would be 1 over 8. If you got the decimal, it would be this number. Okay, so all of these should make sense. Let's take a look at some properties of logarithms next. The two main properties we're going to talk about for this lesson is this one, where it says log base b of b. We talked about this earlier. If these two numbers match, the answer is always going to be 1 because this to the first power is going to be itself. And earlier we also talked about this. We said if this is a 1 right here, this has to be 0 because b to a 0 power is 1. Any number to the 0 power is 1. So anytime you see a 1 right here, you know the result's going to be 0. Now the last thing that we need to talk about is a common logarithm. A common logarithm is a logarithm of base 10, and it's one that we use often. There's actually a button for this on your calculator. It just says log on it. And most of them, it's like 2 or 3 buttons above the on button. So this means log base 10 of 100. So I say 10 to what power is 100? Well, that's going to be 2. So let's take a look at some examples where we have to both apply these properties and just use some logic to figure out some logarithm answers. In example 3, it wants us to evaluate these logarithms using mental math. So notice we have log with no base written. That's the common log base 10 of 1,000. So I say 10 to what power is 1,000? Well, that's going to be 10 to the third power. So 10 to the third power is 1,000. So this log of 1,000 is 3. Now looking at this one, log base 4 of 1/4. So I say 4 to what power is 1/4? And that's going to be a negative 1 power. So because it's a negative 1, log base 4 of 1/4 is negative 1. Okay, so just think through these carefully. Think about what's going to happen. Notice this 1/4 had a 4 in the denominator, so that's why we knew it was a negative exponent here. Next, let's take a look at logarithmic functions. Logarithmic functions are just functions that have a logarithm in them. Now, logarithms are the inverses of exponential functions, so what I like to do is I like to find the points for the exponential function, that is the inverse function. So in my case, this is y equals 2 to the x. I find these points, and then I switch the x and the y values, and it will give me this red graph here. And that's going to be the graph of log base 2 of x. Now, switching the x and the y values will reflect the blue graph across this green line, which is the line y equals x. And the domain and range will also be switched because we switched the x and the y's, so it's going to switch the domain and range. So let me show you an example where I have to graph a logarithmic function. In example 4, it says use the given x values to graph each function, then graph its inverse. Describe the domain and range of the inverse function. So notice we've been given f of x equals 3 to the x. We've been given these x values. So step 1 is to actually make a table of values and put these values into our function and get the y values. When I did that, I got this table of values. So 3 to the negative 2 is 1/9, 3 to the negative 1 is 1/3, 3 to the 0 is 1, 3 to the first is 3, and 3 to the second is 9. Now, to graph its inverse, I'm just going to switch the order of these pairs. So instead of having negative 2 1/9, I'm going to have 1/9 negative 2. Okay, so this is my switched pairs. I have a table filled with them. And now all I'm going to do is I'm going to graph the points in each table and connect all of these dots, and then I'll connect all of these dots. And what we'll have is the graph of f of x equals 3 to the x, and its inverse, which is log base 3 of x. So when I graphed them, I got these graphs. So the blue graph is f of x equals 3 to the x. The red graph is f of x equals log base 3 of x. Now the last thing I need to do is talk about domain and range. Now remember, domain is all the x values I'm allowed to put in. Notice the blue function has a horizontal asymptote at the x-axis. That means the red one will have a vertical asymptote at the y-axis because I'm switching that. So my x values have to be greater than 0. And my range is going to be all real numbers because notice that it goes down forever and it's actually going to go up forever. It's slowly going up, but it will still go up. Okay, so I've written out my domain and range. And again, we were describing them of the inverse function. Domain is x is greater than 0. The range is all real numbers. We have one last question to talk about, and it's an application question. In example 5, it says, chemists regularly test rain samples to determine the rain's acidity or concentration of hydrogen ions. Acidity is measured in pH as given by the function pH equals negative log of the hydrogen ion concentration, where H plus represents the hydrogen ion concentration in moles per liter. They want us to find the pH of rainwater from each location. So they've given us central New Jersey here in this one. All I need to do is take this number from central New Jersey and put it right here where it says H plus and type it into a calculator. So this is what that would look like. In a calculator, I type negative. I press the log button, which is like the second or third one up from the on button. I type in the decimal number they gave, and it gave me about 4.5. I rounded that, okay? So that's it for this lesson. Let me know if you have any questions about logarithms, and hopefully I can answer those for you.